Here are the answers for the day 2 warm-up. Question A, balance the single replacement reaction. We have solid copper being combined with aqueous silver nitrate. Copper is more reactive than silver, so the copper will replace the silver in its bond to the nitrate, and then the silver will become the solid. Balancing the equation means to install any coefficients that might be needed to have equal amounts of atoms on the left side as the right side, but it looks like it's already balanced, just leaving ones in front of everything. Question B, complete the single replacement formulas and then balance them. Solid zinc plus iron sulfate. This has the look of single replacement. We just need to check to make sure that the reaction actually happens. Zinc has to be more reactive than iron to replace the iron in its bond to the sulfate. When you suspect an equation as single replacement, it's always a good idea to look at a table of reactivities to make sure that the reaction will actually happen. On page 361 of the book, there is the activity table. Zinc is higher on the table than iron, so this reaction will occur. Iron will come out of the solution, becoming a solid, which will sink to the bottom of the container. And the zinc will bond with the sulfate, creating zinc sulfate. A zinc ion has a positive 2 charge, sulfate has a negative 2 charge, so the formula is just ZnSO4, no additional subscripts. Because of that, this is already balanced. Question C. Again, just confirm by looking at the activity table on page 361 that this reaction actually will happen. Hydrogen is more reactive than silver, so the hydrogen will bond with the phosphate. The silver will come out of the solution as a solid. Phosphate has a negative 3 charge, so it takes 3 hydrogens to balance a single phosphate. Now we can insert the coefficients to balance the equation. There's only 2 hydrogens here and 3 over here, so to fix that we can put a 3 here, creating 6 hydrogens, if we put a 2 here, which creates 6 hydrogens. That also makes 2 phosphates on the right side of the equation, so we need to have a 2 here to compensate. And then 2 times 3 is 6 silvers, so put a 6 in front of the Ag. Question D. We're missing this reactant right here. So looking on the right side, we see that sodium is mentioned, but there's not any sodium yet on the left side, so the thing that's missing is sodium. Now let's balance the equation. There's 2 OHs here, but right now only 1 over here, so we need a 2 there. That creates 2 NAs, so put a 2 in front of that Na.